So it's a pleasure being here. It's my second time in Pakistan. The first time was in 1990, 32 years ago, coming from East Pakistan, down the Gujarat, Kharagpur highway, which was just a small gravel road back then, and went Schulze Valley, Gilgit, Shiraz, and beautiful, and then ending in Islamabad, Taxila. So I'm very pleased to be here today in Lahore, the pearl of the Punjab. So I had a very nice experience today. It's a beautiful city that I've long wanted to visit. So now I'm the other time. And I'm very much impressed by what you've achieved. I mean, it's an amazing institution. And I just think it's exemplary. And I think it's you said you're really proud of what you have been doing here, the high standard, and also the compassion that you show. It's, I think, amazing, and there should be more known about it. And I think this would also be an example for many other, for mental health care in this region, right? So, honestly, this I really tip my hat. That's really great. So, my name is Schulze. I'm 52 years old. I'm a psychiatrist. I'm a professor at the University of Munich in Germany. I run an institute there. It's called Institute of Psychiatric Genomics and Genomics. That is, we are interested in the clinical presentation of mental illness and its connection with genetic factors, basically, maybe other biological factors as well. So it's primarily a research institute, but we have also a clinic for bipolar disorder. We're very much interested in lithium research, lithium response. That's one thing we do. Then I'm also a professor at the University of State University of New York, in upstate New York in Syracuse, which is like 2.5 hours away from the Niagara Falls, a very nice area. So I spend my time between Munich and Syracuse traveling to the US one week per month. My second home, so to speak. I've been doing psychiatric genetics since my first day in psychiatry. I started in 1997 at the University of Bonn in Germany, which was then the Center for Psychiatric Genetics in Germany, and have been doing genetics ever since in Bonn, Chicago, Washington, Heidelberg, then back to the NIH in Washington, D.C., and then Göttingen in Germany, and Munich, and now also again Syracuse. So I've been studying the Atlantic Ocean. Until I was the president of the International Society of Psychiatric Genetics for 4 years before I spent until 2020, and before I been on the board of the Society for Psychiatric Genetics for many years. One of my main goals at that point was getting the younger generation involved in establishing programs for psychiatrists, for researchers, and now my present function, I'm on the executive committee of the World Psychiatric Association, of which Al Jabed is current president of, and I'm a member of the executive committee, and I hold the post of secretary of scientific sections. We have 68 sections on various areas in psychiatry, and I'm kind of managing and trying to bring them together. I'm trying to stimulate them. I want them to work for WPA to work together, and we also have a very active section, a very good psychiatrist section, and I try to stimulate their work. I try to make sure that they have their voices be heard at the WPA level, especially maybe not directly, like go in little countries where it's even hard because people are always fighting for resources, especially in low middle income country where resources are really, it's be tight. there it's even harder for young colleagues to make their voices heard, start research programs. So the WPA has started a program for young folks to get some seed funding to start a project. So this is what I am, that is my capacity as WPA secretary and what I'm doing. So research wise on the run genetic studies all over the world. And so here today, I think with both capacities, both WPA as a researcher in genetics. Is that enough? Yeah, okay. So this is like the first introduction about me. Just want to learn a bit about you folks here. First, show again, who is a MD medical doctor? Are you medical doctors?
Yeah.
And some are psychologists. Like other professions here, social workers, or so basically all psychologists and all doctors. Great. And so are you looking at are you residents or so you're all residents? Some are already at an advanced stage. Great. And so you all work here in Mountain House, some way or the other? No. Okay. So where are you based?
We are from Services Hospital or we are psychiatrists residents over there.
Okay.
We have come to attend the workshop.
Okay. So and some of you are also
We are working here.
You are good.
I was there to post it.
We are working here.
Okay.
Working at the staff.
Okay.
Working here as clinical.
Okay. So okay, some of you are in the government mental health.
Training.
Good. So again, I have a formal talk tomorrow. That's why I do not always want to just present slides, then there's not much room for interaction. So that's why what I would like to hear from you today is maybe let's gather some questions or what are you interested? So having me here as an expert in psychiatric genetics, as an expert in stimulating research programs all over the world, with a particular focus on early career researchers. What would you like to discuss today? What would you like to hear about? Just because I want you to know what we can talk about. So what are you interested in? Any idea, any questions, suggestions?
So we have a little of idea about inherited disease or genetic disease.
Okay.
So we want to know a detail.
Okay. So some basic concepts of mental illness, of genetics in mental illness, well, that's with different disorders. Okay, well, that's easy. Well, complex topic. So, but it's easy to do because that's what I do. And I even like doing it without any slides. Okay, so I don't know when you first heard that mental illness is heritable. Honestly, when I studied medicine, that was until 1997, from 1990 to 97 in Germany and Catalonia. I didn't hear much about the genetics or the heritability of mental illness. There were still concepts about, well, the mother and the father and conflicts, and there was a lot of psychodynamic explanations that were still prevailing at that time about the origins of mental illness. And at that time, there was not so much this concept of like DSM or all these definitions that we had at that time were based on some assumptions about pathology, endogenous depression, exogenous, neurotic, right? So this was the environment in which I grew up scientifically. And I remember on my last exam, on the very last day of my medical education, on June 10th, 1997, I was asked by the by the examiner, who was a professor of psychiatry, about the difference between endogenous depression and neurotic depression. So I had to tell him about the presentation, about the etiology and conflicts, mother, whatever, and then on June 23rd, I just know it because normally you don't start a job on the 23rd, you start a job on the 1st, but he was one, they wanted me and I had to move there, they wanted me so badly because they didn't have anyone, whatever, so I had to start on the 23rd, just 13 days later. And I immediately joined also the team that was on the board, but I also joined the research team on genetics because that's what I wanted to do. And on the so 13 days after I was asked about the difference between endogenous depression and neurotic depression, I was given a DSM-4 and then skipped into human being and was trained in this. And I had to forget about neurotic depression and endogenous depression. I was told about, we don't do this here anymore. We don't endorse this concept. We just look at the phenomenology. So this was a major paradigm shift. And at that time, basically, I learned about this heritability, which I hadn't learned much about during my studies. Again, this was a totally different era. And of course, some of it depended a bit on the school, on the teachers. So nobody talked about heritability. But suddenly I learned about heritability. I mean, I don't know whether you know the numbers, but the heritability estimates that we know from twin studies, combined evidence from family studies, twin studies, adoption studies, we know that the heritability, so the percentage, the contribution of heritable factors, contribution to the phenotypic variance, is like 8% for schizophrenia, bipolar disorder, maybe major depression, being more heterogeneous, 40%. Other disorders, panic disorders, anxiety disorders, more like in the range of 20%. But this is even if it's only 20%, that's a huge chunk. But the disorders that we mostly treat, like schizophrenia, bipolar disorder, depression, have high estimates of heritability. So this was for me a major, not shock, but it was a major enlightenment that there is a strong genetic basis, a heritable basis. Now, when you know that there is a heritable basis, then you think of genetic factors, right? You want to find the genes. That's what you want to do. Wow, my tea is coming. That's great. That's because I love the cardamom tea and I can drink it all the time. So that's thank you very much. So now, is that the concept of heritability? Did you in your studies, were you told about? Did you learn at one point these numbers? Yes, right. Yeah, right. So then you want to find those genes, right? And now psychiatric genetics is not a new field. Think about, it started basically in the first half of the 20th century, actually like in Germany, Munich, and that's where people, there's almost schools, I didn't see that. Thank you. So they, at that time, in the beginning of the 20th century, people in psychiatrists and all sorts of medicine, they rediscovered sort of the laws set by Gregor Mendel, the Mendelian inheritance, the peas of different colors. So in many fields of medicine, especially psychiatry, they wanted to apply these laws and they wanted to find out, is a mental illness, schizophrenia, is it heritable as these traits described by Mendel? Is it recessive? Is it dominant? So in Munich, they started doing family studies in the 1920s. It was unheard of. And they had a research department, they had a car where they would drive around and recruit families, something that we do nowadays, right? But at that time, it was revolutionary. And the idea was to study families, and start with a patient and recruit all family members. You start with someone who's not affected and recruit all the family members, and you compare. You want to see, are there more people affected in the family of someone who is ill, him or herself, compared to someone who's not affected. And the hope was you'll find a clear dominant pattern of inheritance or a recessive one or something. However, that's what they didn't find, right? They wouldn't find, maybe some families looked as if they had a recessive pattern or a dominant pattern, but overall, you couldn't discern a clear pattern. So that were the early attempts at psychiatric genetics. Then later came many twin studies and so forth. And of course, there's a sad part to it as well. As you know, the 20th century was the idea of eugenics was very prevalent. Now, in Germany, that led to the mass murder of many synthetic patients in Nazi Germany, which is a horrible part of German history, especially German psychiatry. But it was definitely, there were these thoughts all over the world that, that you can use eugenics to purify population, which is a horrible thought, but also scientifically ridiculous to the idea that by eradicating some disorders, you would then purify society. These thoughts were around because even in the afterworld in other countries in the Western world, in Canada, Scandinavia, so people were sterilized and so forth against it. So these misconceptions about mental illness and genetics were still very pervasive. And so psychiatric genetics had a hard time getting back into the real science field after World War II because it was also abused. Yes. Sure.
Why do you think that the local psychiatrists in revolutionary Freud and friends wrote very hard?
Yeah.
But they have a very different explanation of psychiatric like more psychological, more social inspired. So I think that why Freud has forwarded the explanation of mental illnesses in some way on the psychological aspect. These explanations have actually had a different impact altogether on genetics and on the
Yeah.
That's what my opinion is.
Sure, but I think nowadays, I would say nowadays we do not say that these concepts are wrong or something. I would say that today we live unfortunately we live in times where we try to integrate various concepts and even lived experience are now more factored in again in terms of epigenetics. So I think we are at a while we are not advanced in other fields of humanity, when you think of course, I think in terms of science, we have made advances and we are not so sold on one theory. So of course, my emphasis lies on genetics, but even Freud would have said that there's a biological basis. But I think what we are now trying to understand, even with genetics or epigenetic approaches, is how environment, how trauma, and so forth impact on the background. So I think today we are in a better shape to integrate this. So what I want to say is, so nowadays we are with this concept that genetics is something that is always there and we cannot change anything about it, and then come these horrible concepts of eugenics. So this is gone because we now consider genetics of mental illness. We do not consider the genes as something that the genes are not bad or good, right? Everybody has the same genes. You have different variants. Okay, we differ in sort of variants, but so we call these genes that may be behind or underlying mental illness or any other disorder vulnerability genes. given certain environmental factors, whatever they may be. So this is the whole, I think this is a fundamental shift that we are looking at certain vulnerability or susceptibility genes, variants that, given certain environmental factors, may push you over a certain limit or threshold, then cause you having mental illness. So, yeah,
We also use the express vulnerability.
right,
Like our circumcision already.
right,
All checkers vulnerability. Like
Exactly. absolutely. It's a good point. And we call it also like the multifactorial model, right? So we definitely have many factors and things. And I always tell people you can have, let's say, think of monozygotic twins. They're identical genetically, but even if one twin has schizophrenia, only 50% of the time the co-twins will have schizophrenia. So although they are genetically identical, there's something else. There's environment, and there are some factors that apparently protect this co-twin from becoming ill. So we need to see whatever we do in genetics as just I'm trying to understand vulnerability. When I started in 1997, the concept was that the theory was that there will be a handful of genes, maybe not a handful, but maybe 3 or 6 handfuls, 10, 20, 30 genes that have a whopping effect, that have a relative risk of 5, or, so that once you have that gene, you're very likely to have, or the variant, you are very likely to have the disorder. Now, this was considered the oligogenic model. So oligogenic meaning several, few genes will be sufficient, or having these variants will be sufficient in you having the disorder. So, and that's why we employ methods that were designed for traits, for visited illnesses like Mendelian illnesses, methods aiming to find variants or regions on the chromosomes that harbor these genes. Maybe you've heard of linkage analysis, linkage studies, where you collect or recruit large pedigrees, pedigrees meaning families with several affected, and you want to see what do families that are what members of the same family that share have the same disorder, what percentage do they share susceptibility genes? So, and which are, you want to find the linkages that are linked, that's why linkage, to a certain phenotype. Now, that's 1997 when I started, and I was told, okay, let's recruit 100 families, and maybe there was a technique called sibling pairs, you would like these 2 sibling pairs that were both affected, and the hope was that by linkage analysis we would narrow down the regions. Now, maybe some people found something. They were happy, they presented it in the paper or scientific journal and so forth. And we then realized at one point that, well, one study would find something, another study would not find anything. That's the problem of replication and non-replication. So that was around the year 2000, and people realized, well, we cannot go on like this. So the notion that there is, that's oligogenic, isn't really true. Can we find those handful of genes that have a whopping effect? In parallel, at that time in genetics, started making major progress because the Human Genome Project came to them. And you had all the genetic variations suddenly available. Because before we did these linkage scans with a few hundred markers, genetic markers that were placed far away from each other on the chromosome. And now we had these single nucleotide polymorphisms, these single base exchange markers that could be placed relatively densely at a relatively sparse, relatively close distance, and you could scan the whole genome at a much higher distance. That gave way to analyses called genome-wide association studies. And they have become now the bread and butter of complex genetics. So, and that's not only psychiatry, all major disorders, all major ailments, basically, cardiovascular, cancer, many disorders are complex disorders and have been studied through genome-wide association studies, where you collect large samples of patients and large samples of whatever it's called, healthy controls. You don't call it healthy controls anymore. So, if there's a control group that they don't have this disorder in question. So that really propelled the field. And nowadays we have large consortia, like we say, the Genomics Consortium, that bring together researchers from all over the world, and they have, these consortia efforts have established large sample sizes. And this suddenly, we learned that the genetic architecture of mental illnesses, psychiatric disorders, schizophrenia, bipolar, is different from what we thought. So the concept of oligogenic origins pathology is no longer the concept of choice. That's not any, we cannot, the data does not support this. So instead, the data support polygenic model. So that means several hundreds, maybe thousands of genes do contribute. Each of the genes having only a small effect. Now, I consider this still a major progress because from a conceptual point of view. However, it's a disappointment in terms of finding the genes. It would be much cooler, greater if you had 30 genes, you find them, and then you explain everything. Well, that's not what it is like, right? So we know there will be several hundred genes. We don't know. For schizophrenia, we have now identified roughly 300. For bipolar, 160. Same for depression. And each of these genes have only a small genetic risk association. So you have to look at them in their combined action, and not all of them have. So when we say 270 for schizophrenia, 300, then that doesn't mean that. Yeah. Okay. Great. Yeah. Sure. I don't know where the next session starts.
I don't know.
I was not asked you to come and change and talk about architecture, research publication, things
Okay.
like that.
Great.
But you carry on, I don't.
Okay.
Thanks.
I started in 1900. We are already in the year 2000, and so that's we good. So I not all when we now say we have 300 genes for schizophrenia. That doesn't mean that 300 vulnerability genes. That doesn't mean that each and every patient or each and every family where a patient's from has these 300 variants. There are some variants that are more that are one family, others are, so combined we have this. Now, again, we have to debunk the initial idea that we can pinpoint the genes, right? It is a collection. It's a background. And that's why the concept of polygenic scores has now evolved. So basically you take the combined information that you have, and you can take that information and test in other persons what their overall polygenic load is. Now there's a lot of controversy whether this is clinically meaningful at this point. It may, right now, honestly, I have to say, one of the best predictive factors is still family history, right? I mean, if let's say a couple comes to you and say, well, I'm bipolar, my wife is not bipolar, what are the chances of our kids having bipolar disorder? Well, at that point, you don't have to do any genetic tests, so you have the mere epidemiology, it's tenfold increase over the general population. But that only means maybe instead of 1% or 10%. So there's still a chance of 90% that the child will not have bipolar disorder. And this is still one of the best predictive factors. However, I truly believe that at one point we will be able to use all those scores that we get out of these large data sets to make better predictions. Get a score for diabetes, for heart cardiovascular disorder, disease, for mental illness, for other things. And factor maybe also in some rare variants. We have to talk about this. The genome studies, they look into these common variants, there are also rare variants that actually come with a higher genetic risk. And if you factor those in, well, they explain maybe in a few variants, in a few individuals, actually a high percentage of the phenotypic variability. So I'm thinking of a scenario where one, especially for therapy response to medication, in response to any certain treatment regime. So I think that that's where genetics will be moving, that we use genetic parameters like any other parameters, like family history, environmental factors, nutrition, physical activity, then add polygenic scores from various disorders to have one large equation in an algorithm, and that will tell you more about whether a person will respond to a medication or to certain treatment. I'm very skeptical that we will be able to use genetics as something that will predict 100% whether someone gets the disorder or not, or to find the genes. I think that's not where we are. I think this field will be used for making better predictions about the course and outcome. And we're not only talking about genetics or genomics, we are now looking at proteomics. We're looking at epigenetics, methylation that reflects environmental factors. We are looking at transcriptomics. There's even microRNA that has something to do with regulatory processes. We've just started doing some sense of lipidomics. So there's so many factors in the omics world that need to be taken into account. So this is basically my final statement. I think the world of omics is still, we have just understood better the world of genetics and now genomics. Now, we can add more samples, and that's good, and especially we need more samples from other parts of the world, because right now we are very biased towards the Western world, America, Europe, Australia, maybe also Asia, Japan, or China, but like the African continent is totally still like unexplored in terms of second genetics. Also, Asia, that part of the world needs to be addressed, and like she found now as part of many projects as well, I understand. And so this is urgently needed. So we will learn more about the genetic underpinnings of disorders, the genetic background, but in order to completely understand biology, we definitely need more other neuroscientific approaches, imaging, but also the other omics, proteomics, and metabolomics, and these factors. And I think that will be the next frontier. So again, I think these omics approaches will help us in the future, help us tailor strategies, approaches to the individual patient. That's what I open with. I truly believe in it. Not anymore in pinpointing the origin, but making use of this information to a certain degree in improving our treatment, and maybe also prognostic measures. So that's my monologue. So there may be some questions, and I also don't want to have your time. So that's basically my statement. Questions, comments?
So, the only reason behavior actually.
Sorry, what is that?
Alcoholism.
Yeah.
Actually, it's very.
Oh, alcoholism. Yeah.
How quickly drug heredity in family and gene?
How inheritable is it? Honestly, I don't know the heritability of, alcohol. I think it's also in the 50s somewhere. So it's definitely, it's a behavior, and it has a clear, but of course with substance abuse, you have one exogenous factor, right? So you have not only, so you need the substance for this to show, right? And we know that the heritability actually depends a lot on the environment. So to be, it goes into the equation of heritability. And so heritability estimates for alcoholism are totally higher in societies where alcohol is not so much available, or where it's not allowed, like Saudi Arabia. But I consider it as it's a disorder like any other, well, psychiatric, psychological illness. It's a behavior, but there is underlying mechanism, and we all know about these theories about reward mechanisms and so forth. And they are triggered, or they triggered by this substance. Of course, if you don't have a substance, then you don't have it. But I don't see it any different. For me, it's not any different than all the other disorders. From a genetics standpoint, but you need, of course, the environment trigger. You can think of, there will be, maybe there is some parallel to psychosis. Think of drug-induced psychosis, right? So maybe there are some cases of schizophrenia that would never be there if it weren't for drugs. So there's some trigger. So I think this is not really well studied yet, because unless we have a clear, there's this criterion whether these symptoms started after, drugs, psychotic symptoms, and if you can really say, yes, it has only to do with drugs, then it's not schizophrenia, but you can rarely really exclude that. And we know these cases where maybe a person once took a drug or a few times, but then the whole thing stayed on forever. So there is an environmental factor, and I would say this is maybe akin to the situation with alcoholism. So this is something we need to explore further. So that actually adds to the environmental components.
I think that most of us can now foresee that with the more genes and lineages that are identified, so it will have an impact on the early psychiatry and also on stigma discrimination as well.
Yes.
But we are not sure that where this program, like it could be the stigmatized people or freedom of the owners of their acts.
That's a good point, because I would argue that if you consider, when you consider mental illness in the same way as intellectual illness, then it will take away stigma, because you can say, look, there is a clear biological basis. If you have cancer, you are not stigmatized against. You are not, nobody says, oh, you got cancer because, whatever, you're a bad person or something, or you're weird or so. So I think if the people, the population knows, the society knows that somebody who's mentally ill, somebody who's bumped now as a patient, is there because his or her biology triggers that. I think that should help alleviate stigma. That should help also increase compassion towards this person. But we all know it's not easy. We know that it's always accompanied by the stigma, and the stigma doesn't go away. We always have to fight. It's not like that as much as science advances, we still have to keep fighting against stigma. So it's not like that it will go away. That's unfortunate. I think so. It's a constant fight. You cannot give up this fight, because it's not like that at one point everybody knows that mental illness is heritable. At one point everybody knows because it's heritable, it's biological, and so there's no need for stigma. But people are afraid of the symptoms, and that's why there will be stigma. So we have to constantly fight for it. Maybe, I don't know. 100 years from now, nobody will, have any, there will be no more stigma, but I doubt it, because we have been telling this for generations, but maybe we will do more, but I think that's why we need these things, we need these conferences and support to present them. I would say maybe in Germany, there has been a lot of awareness and awareness building. People see that it is, there is biology and there's a medical model behind it. But I still see some discrimination that people don't really see as discrimination. When you go to the supermarket in America or so, and there's always a donation box for cancer, children's cancer, hospitals for cancer. Well, cancer gets a lot of funding, much more than, it's good that they get funding, but there's never a drop box, or there's never a donation box for mentally ill, or for kids with mental illness. It's not considered, I know, that's the problem, that it's still not considered. They show kids that went through chemotherapy, no hair, oh, poor kid, yes, poor kid, yes, right. But they would never show, there's never a donation box for really mentally ill kids. So this is where society still has a lot to do. And I hope that biology
It's really good. Mental disorders people don't get it when they go. This is what we all.
Yes.
Yeah. For a cancer patient might be there with maybe for us to do it better. But generally it is shown that.
I totally agree with this concept, but I always say basically if you have diabetes, you always have diabetes. It doesn't go away. It might even get worse, so it may end up having cardiovascular problems as well. But of course, we see, and we have to, I think we shouldn't fool ourselves, we shouldn't fool the others. We have to admit that there are conditions that are very, very chronic. We know it. And but those that are not chronic, these 30% that will show, we know that 30%, 30% is average. Well, I think it still applies. There will be people who are psychotic and they may benefit from treatment if they take treatment for a long period or whatever. They may be even cured if you make it's a fight for it. There are patients who would be for 10, 20 years until it was diagnosed, they suffer horribly because of mania and depression. And we find the right neutralizers for them, and they can live a normal life. And I think this we have to show. But we also have, we shouldn't fool ourselves. We should say yes. There are those that have those chronic conditions, and at this point we cannot really help them. Then institutions like Fountain House and so are important. Then it's more the social aspect, the social work that's important. But I think biology, in terms of medication, can do, and moderate or also severe depression, mild depression, and so we can treat good treatment programs, psychotherapy, plus medications. We can. So I think we should get this message out.
These instances are very impactful and interesting. I don't want to interrupt because just I want to know, can we take people after testing?
A tea break.
She is always welcome. No, but isn't there now?
I think we can start off with the teaching.
Yeah.
Try to achieve.
Yeah, but I'm around the next 2 days anyway, right?
Yeah.
She is always
Yeah. So that's part of the
स्टॉप करना है एंड स्ट्रीम करना है क्या करना है एंड पूछो ना क्या करना है
एंड स्ट्रीम नहीं वो बंद हो जाएगा फिर दोबारा करना पड़ेगा
लाइव चल रहा क्या करना
लाइव बंद ही होता था कॉल
बंद करना है के बाद दूसरा क्वेश्चन चला
लेकिन मान
अच्छा यार टीम ब्रेक हो गया अब इसको एंड करना है क्या करना है वो ये सारा रिकॉर्ड कर रही है कौन फिर नहीं तो दोबारा नया सेशन बन क्या वो वीडियो एंड स्क्रीन कर दो यार your screen will stop immediately and you will no longer to be live. End करना